You use apps every single day, right? But have you ever stopped to think about the invisible conversation that's happening just behind the screen? Today, we're going to pull back the curtain on that vital link, the bridge between our favorite apps and the databases that hold all their information. I mean, think about it. Your favorite game. How in the world does it remember your high score after you've closed it and come back a week later? Or how does your shopping app keep track of what's in your cart? It kind of feels like magic, but it's actually some really clever engineering. Well, the secret is this constant, invisible conversation. On one side, you've got the app's code, the part that's actually running on your phone. And on the other, there's a huge database, which is basically the system's long-term memory. They are talking back and forth all the time, saving your stuff, fetching your stuff. It never stops. But here's the catch, and it's a big one. These two systems are fundamentally different. They think in different ways, they operate on different principles, and they don't even speak the same language. Not even close. So this is the story of how we build the bridge to connect these two very different worlds. All right, so let's really dig into this. Just how different are these two worlds? We're not just talking about a simple language barrier here. It's a totally different way of thinking about and handling information. Picture this, your app's code, written in something like Python or Java. It's like a worker on an assembly line. It meticulously handles one single item at a time. But the database, which speaks a language called SQL, is more like a warehouse manager. You don't tell the manager how to find the box step by step. You just declare what you want, and it brings you back the whole set of results at once. Okay, so how on earth do we connect them? The most common solution is something called an Application Programming Interface, or API. You can think of it as a rulebook, a standardized set of commands that lets these two totally different pieces of software talk to each other. This API is basically the blueprint for our bridge. And this core technical challenge, it actually has this fantastic name, impedance mismatch. I love that term. It perfectly describes this exact problem, trying to make a system that thinks one at a time communicate with a system that thinks in entire sets. It's like trying to fit a square peg in a round hole. And this slide shows the classic solution. We use something called a cursor. Imagine the database hands you this giant stack of papers with all your results. The cursor is basically your finger, pointing to one line at a time, letting the app read through that whole set of data sequentially, just the way it likes. It's the perfect translator. But here's the thing. Building this bridge isn't just about translation. It has to be strong and, most importantly, secure. Because if you build this bridge the wrong way, oh boy, you are opening up a massive, massive security hole. A vulnerability that we call SQL injection. This famous webcomic from XKCD just nails the idea perfectly. You've got this mom who's a programmer, and she names her son in a very creative way. See, his name isn't just a name. It's also a database command that tells the system to delete the entire table of students. It's hilarious in a comic strip, for sure. But just think about the real-world implications for a second. What if an attacker could do that to your bank's records, or your medical history, or an airline's booking system? The consequences would be absolutely catastrophic. So it all comes down to how we build that query. On the left, you see the really dangerous way, just mashing the user's input directly into the command. This is like leaving the front door of your house wide open. But on the right, you see the secure method. It uses placeholders. It's like telling the database, hey, this first part is the command, and this second part is just data. Do not, under any circumstances, mix them up. This is SQL injection. And what's crazy is that it's been around for decades, and yet it is still one of the most common and damaging ways that systems get hacked today. And the real-world consequences? They are brutal. When the Affair website, Ashley Madison, was famously hacked, the attackers literally mocked the company for failing to prevent these basic attacks, calling their security, quote, completely amateur. A single, simple vulnerability like this can absolutely demolish a company's reputation. So, what's the solution? The professional, rock-solid way to do this is something called prepared statements. The app sends the structure of the command first, the safe part with the placeholders, to the database. The database then compiles that safe template. That placeholder is like a variable. The database now knows that whatever data you stuff in there later is just a value. It's never a command. Not only is it faster, it completely slams the door shut on injection attacks. Now, the API with prepared statements is definitely the most common bridge, but it's not the only game in town. There are a few other ways engineers have tried to solve this problem. One idea is to basically augment SQL itself, add more programming stuff right into the database language. The upside, your logic is super close to your data, which can be really efficient. But the downside, man, your SQL code can get incredibly messy and complex, and it starts to blur the line between your application and your database. Then there's another really popular approach, the Object Relational Mapper, or ORM. Think of this as a kind of magic, prefabricated bridge. Instead of writing raw SQL, you just write simple code and say Python, like user.get ID equals 123. The ORM does all the messy SQL translation behind the scenes. It's incredibly convenient for simple stuff, but boy, can it become a real headache when your needs get more complex. Okay, finally, let's zoom all the way out. Because our bridge doesn't exist in a vacuum, it's part of a much bigger city plan, what we in the biz call application architecture. So the older, simpler design is what we call a two-tier architecture. In this setup, you've got the client, your phone or your browser, talking directly to a server that does everything. It handles the business rules, it manages the database, the whole shebang. It's simple, but it's not very flexible or scalable. But the modern standard, what you see pretty much everywhere now, is the three-tier architecture. Here, we split everything into its own layer. Tier 1 is the presentation layer, what you see. Tier 2 is the application logic, and Tier 3 is the data management layer. And our bridge, that's what connects Tier 2 and Tier 3. And this separation is absolutely key. It means you can have one team working on the user interface, and they don't have to know anything about the database. You can upgrade your database technology without having to rewrite the app on your phone. This creates systems that are way more secure, scalable, and easier to maintain in the long run. So the next time you add something to your shopping cart or you check that high score, just take a second to think about that invisible bridge working hard behind the scenes. It's a really complex, carefully designed piece of engineering that connects what you see with the data you need. It makes you wonder, what other invisible bridges are quietly shaping our digital world?